Okay, I wanted to do a lesson on scientific notation. So first we should talk about what the kind of basic setup of scientific notation is. It is a number that is a times 10 to a power. Now, a will be a number in between 1 and 10. So it could be 1, but it cannot be 10. So basically we're saying if we have a 10, then we would need to rewrite it so that it was a 1, okay, using exponents in powers of 10. N will be an integer. Okay, so that's kind of the basic of scientific notation. So if we have a number, let's say 621.1, and we want to write that into scientific notation. Well, first we should see kind of where the decimal should be. So 621.1 needs to be in between 1 and 10. That means it needs to be 6.211. Now, what is the exponent, right, on the 10? Think about it this way. We want to know how many tens and in which direction we need to move the decimal point to get back to the original number. So we need to actually think about this should move this way twice, making the number bigger, right? So to go from 6.211, we would need to get bigger to go to 621.1 by 2 places. So that means it's a positive 2. Now, if we want to convert a number from scientific notation into standard format, say we had 7.93 times 10 to the negative third. Well, then negative 3 means we move in the left direction, kind of like we're moving on a number line, in 3 places. So 1, 2, 3, that's our new decimal. Fill in with zeros. You can put a 0 out front just as a placeholder for the decimal. So it would be 0.00793. That would be the standard form of that number. All right, so after this, we can do a bit more with numbers in scientific notation. We can multiply them, we can divide them, and it's a little bit kind of specific how we need to do that. So let's look at a couple of examples of those types of problems. So say we had 1.3 times 10 to the 7th times 3 times 10 to the 6th. So that means we need to look at the like things together, meaning we need to multiply 1.3 and 3 together, and multiply 10 to the 7th and 10 to the 6th together. So 3 times 3 is 9, 3 times 1 is 3. Both of these numbers only have 1 decimal place together. So that means 1 decimal place, 3.9. So we have 3.9 to start off with, times 10 to some power. Now, 10 to the 7th times 10 to the 6th, exponent rule, same base being multiplied together, means you add the exponents. So 7 and 6 is 13. Now there's one last thing we need to check for. When we do multiplication or division of scientific numbers, we must make sure that our number is in scientific form now that we're finished doing the multiplication. 3.9 is in between 1 and 10, okay? If it weren't, we would just need to think about moving it again and how that would change the exponent on the 10. We will do one of those. So next, let's do a division. If we have 8 times 10 to the 7th over 2 times 10 to the 4th, well, this is a division, right? We treat it just like we did the multiplication. So 8 divided by 2 is 4 times 10. Now, Multiplication, same base, means we add. Division, same base, means we subtract. So 7 minus 4 is 3. Again, check that your number is in scientific format. 4 is in between 1 and 10, so we're good. That would be our answer to that one. Okay, so let's do a more advanced, division. So if we start off with 2.7 times 10 to the negative third over 9 times 10 to the negative ninth. Well, again, look at it as number and tens separated. So we're taking 9 into 2.7. Forget about the decimal for right now. We'll come to that afterwards. 9 does not go into 2, so put a 0. 9 does go into 27 3 times. Well, out of our original numbers, only one decimal place. So one decimal place means 0.3. So 0.3. Now let's look at the tens. We have 10 to the negative third divided by 10 to the negative 9. Same base, division means you subtract. So that means we have 10 to the negative third minus negative 9. Keep it the same, you're just subtracting the bottom number. So minus minus really means plus. Negative 3 plus 9 is 10 to the positive 6. Now, are we in scientific notation? That's the next thing we need to check. 0.3 is not in between 1 and 10. So let's look at 0.3 just on its own. Forget about the times 10 to the 6 for a second. What do we need to do to that number? Well, to make it in between 1 and 10, we need to make it into 3, right? So that means, what did we just do? We moved it this direction. So if we need to move it back into 0.3, that would be a 10 to the negative 1. Okay, so that means we have 3 times 10 to the negative 1. Now we need to remember that we have times 10 to the 6th. So 10's being multiplied, so same base being multiplied, you add. So that means we have 3 times 10. Negative 1 plus 6 is 5. The other way that you can think about this is that you need to make this number bigger to make it into scientific format. Meaning you're going to use one of these tens, essentially, to make it a bigger number. Because that's what a positive exponent does, is it makes the number bigger. So, we use one of its tens, it goes down to 10 to the 5th. It's the same kind of thought process. This is just written out all the way through. Okay, that's scientific notation.